Hello friend, welcome to the abstract algebra class. It is class 69. In this class we will define order of permutation and also we will solve a question about this concept order of permutation. Let us define this concept. Let Sn be a permutation group defined over n samples and F belongs to Sn. F is a permutation belongs to symmetric group n. Sn. Fm is the least positive integers such that f to the power m is equal to I, where I is the identity permutation in Sn, then m is called order of f and is denoted by order of f is equal to m. Here, if we have any permutation as 1, 2, 3, 4, 3, 1, 2, we have like this permutation. Identity permutation is like this. I is equal to 1, 1, 2, 2, 3, 3. It's called identity permutation. Already in the previous lecture we said these things. Again we review that f is equal to 1, 2, 3, 4, 3, 1, 2. It be a permutation, then identity permutation is 1, 2, 3, 1, 2, 3. Every element has image as like itself. Image 1 is 1, image 2 is 2, image 3 is 3. It was the definition of permutation and it is the identity element. We now want to solve this question. Find the order of the permutation f is equal to 1, 2, 3, 2, 3, 1. Image 1 is 2, image 2 is 3, image 3 is 1. First, we want to solve this question. Solution. Given that f is equal to 1, 2, 3. 2, 3, 1. Now we want to find f square is equal to f, and to f we know the multiplication of permutation. 1, 2, 3, 2, 3, 3, 1 into 1, 2, 3, 2, 3, 1. It is equal to, here we have 1, 2, 3. Image of 1 is 2, image of 2 is 3. Another element 2, image of 2 is 3, image of 3 is 1. Image of 3 is 1, image of 1 is 2. It is not identity element. F to the power 3 is equal to f into f square is equal to f we have 1, 2, 3, 2, 3, 1 into f square we have 1, 2, 3, 3, 1, 2. It is equal to, here 1, 2, 3, image of 3 is, image of 1 is 3, image of 3 is 1, image of 2 is 1, image of 1 is 2, image of 3 is 2, image of 2 is 3. It is identity element. Therefore, f to the power m is equal to f to the power 3 is equal to identity permutation. Therefore, order of f is equal to 3 is equal to m is equal to 3. It is order of this permutation. Find the order of permutation f is equal to 1, 2, 3, 4, 5. we want to find the order of this permutation. Solution given that f is equal to 1, 2, 3, 4, 5, it is equal to 1, 2, 3, 4, 5. We do not consider first element, second element is 2, 3, 4, 5, then first element will goes to the end. It is the permutation 1, 2, 3, 4, 5, 2, 3, 4, 5, 1. We want to find order of this permutation. First, f squared is equal to f into f is equal to 1, 2, 3, 4, 5, 2, 3, 4, 5, 1 into 1, 2, 3, 4, 5, 2, 3, 4, 5, 1. It is equal 1, 2, 3, 4, 5. We know that in image of 1 is 2, image of 2 is 3, image of 2, 3, image of 3 is 4, image of 3 is 4, image of 4 is 5, image of 4 is 5, image of 5 is 1, image of 5 is 1, image of 1 is 2. It is f squared. We now want to find f cubic and f to the power 4 and f to the power 5 everywhere, which we got identity element, and then the power of is order of permutation. F cubic is equal to f into f squared is equal to f, we have 1, 2, 3, 4, 5, 2, 3, 4, 5, 1 into 1, 2, 3, 4, 5, 3, 4, 5, 1, 2. It is equal to 1, 2, 3, 4, 5. Image 1 is 3, image 3 is 4, image 2 is 4, image 4 is 5, image of 3 is 5, image of 5 is 1, image of 4 is 1, image of 1 is 2, image of 5 is 2, image of 2 is 3. F to the power 4 is equal to f into f squared. F cubic is equal to f 1, 2, 3, 4, 5 f 2, 3, 4, 5, 2, 3, 4, 5, 1 into f cubic. We got 1, 2, 3, 4, 5, 4, 5, 1, 2, 3. It is equal to 1, 2, 3, 4, 5. 1 the image of 1 is 4, image of 4 is 5, image of 2 is 5, image of 5 is 1, image of 3 is 1, image of 1 is 2, image of 4 is 2, image of 2 is 3, 5, 3, 3, 4. It is not identity element, identity permutation. We have to find f to the power 5. F into f to the power 4 is equal to 1, 2, 3, 2, 3, 4, 5, 2, 3, 4, 5, 1 into 1, 2, 3, 4, 5, 5, 1, 2, 3, 4. It is equal to 1, 2, 3, 4, 5. Image of 1 is 5, image of 5 is 1. Image of 2 is 1, image of 1 is 2, image of 3 is 2, image of 2 is 3, image of 4 is 3, image of 3 is 4, image of 5 is 4, image of 4 is 5. Actually it is identity element. Therefore order of f is equal to n is equal to 5. It is the solution of, there is three example, three homework you have to do by yourself. Find the order of the following permutations. Number 1, number 2, number 3. Number 1, f is equal to 7325. Number 2, f is equal to 145.7. Number 3, f is equal to 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 5, 1, 4, 6, 8, 7. Here the only things which you have to know how to make this form of this permutation. 1, 2, 3, 4, 5, 6, 7. We have 7 numbers. Okay. Now there didn't mention it 1. 1 is image of 1 is 1. 4 also didn't mention it. Image of 4 is 4. 6 also didn't mention it. Image of 6 is itself. Now we want to write this one 7, 3, 2, 5. How we can write the image of this element? Image of 7 is 3. Image of 3 is 2. Image of 7, image of 5 is, image of 2 is 5. Image of 5 is 7. According this rule, we can write image of 2 is 5. Image of 3 is 2. Image of 5 is 7. Image of 7 is 3. You can make this as according this rule. Now we want to define cyclic permutation. What is the cyclic permutation? And we will bring some example about cyclic permutation. First we want to define, let us consider a CTS equal to A1, A2 and so on AN, and a permutation F defined on S as F is equal to A1, A2, AK plus 1, AK plus 2 and so on AN, A2, A3 and so on AN, AK plus 1, AK plus 2 and so on AN. That is F of A is equal to A2, F of A1. F of A1 is equal to A2, F of A2 is equal to A3, and so on. F of AK is equal to A1, and F of AK equal to itself. F of AK plus 1 is equal to itself, and F of AK plus 2 is equal to AK plus 2, and so on. F of AN is equal to AN itself. This kind of permutation is called cyclic permutation of length K. And degree n. How many elements we have? It is the degree of permutation. We have n elements, so the degree is n, and permutation is, the length of permutation is K. It is represented by A1, A2 and so on AK. It is equal to A2, A3 and so on AK A1. etc. We can write another form of this A3, A4 and so on AK and so on AK A1, A2. we can write this kind of in this form we can write this permutation. etc. Also we can A4 then we transfer A3 in the end of the bracket after A2, which is a cyclic of length K or K cyclic. We can say this kind of permutation K cyclic or length of K. Then the number of elements permuted by a cyclic is called its length. How many elements we have here? K element permuted. So the length of cycle is K. Example, consider the set is equal to 1, 2, 3. It is a clear example for permutation, cyclic permutation. S equal to 1, 2, 3, 4, 5, 6, 7. And a permutation if defined on S as f is equal to 1, 2, 1, 1, 2, 3, 3, 4, 4, 5, 7, 5, 5, 6, 6, 7, 2. So it is equal to, this permutation is equal to, we can write 2, 3, 4, 7. Because here they are not cyclic. 5, 1, 1, 5, 5, 6, 6. They are repeated. So the cyclic permutation is 2, 3, 4, 7. Or we can write 3. After image of 3 is 4, image of 4 is 7, image of 7 is 2. Or we can write 4, image of 4 is 7, image of 7 is 2, image of 2 is 3, etc. We can write this in these forms. Therefore, F is a cyclic permutation of length 4, or we can say 4 cycle. 4 cycle. Actually, this permutation has 4 cycle. The number of the element which is here we wrote that 1, 2, 3, 4. It is 4 cycle. And example, consider the set is equal to 1, 2, 3, 4, 5, 6, and a permutation f defined as on S as f equal to 1, 2, 3, 4, 5, 6, 3, 1, 4, 6, 1, 4, 6, 5, 2. Now we want to write this permutation as like this. 1, image of 1 is 3, image of 3 is 4, image of 4 is 6, image of 6 is 2. Or we can write like this. 3, image of 3 is 4, image of 4 is 6, image of 6 is 2, image of 2 is 1, etc. We can write in different ways. F is a cyclic permutation of length 1, 2, 3, 4, 5, length 5, and of degree, how many elements we have? 6. Degree is 6. Here is two definition. Definition 1: a cyclic of length 1 is known as identity permutation. If we have f is equal to a1, a2, a2, a3, a3, an, then the length of this permutation is 1. F of a1 is equal to a1, f of a2 is equal to a2, f of an, and so on, f of an is equal to an. This kind of permutation is called length of 1. It is identity permutation actually. Those permutation which they have length 1 is called as identity permutation, like I equal to 1, 2, 3, 1, 2, 3. It is the length of this permutation is 1. Therefore, this kind of permutation is called identity permutation. It is the general form of identity permutation. Here f is equal to this permutation. Definition 2: a cycle of length 2 is called transposition permutation. We call this transposition. Number 1 is f equal to a1, a2, a2, a1. Here the length of permutation is 2. Therefore, it is called transposition permutation. Second one, f is equal to 1, 1, 2, 2, 3, 4, 4, 3, 5, 5. Here is the length of this permutation is 2. It is not permutation, just 3, 4. We have 2 cycle, therefore the length of this permutation is 2. Therefore, f is a cycle of length 2. Therefore, f is called a transposition. Disjoint cycles at CTS equal to a1, a2, and so on, an, and f, comma g are 2 cycles defined over S. If the cycles f, comma g no, they don't have common elements, they don't have joint element, then f, comma g are called disjoint cycles. Here is an example: S equal to 1, 2, 3, 4, and 7 up to 7, and number 1 f is equal to 2, 3, 4, g equal to 1, 5, 6, 7. This implies here, if we see, there is no joint element, or they don't have common element. Therefore, we say that f and g are disjoint cycles. Number 2, f is equal to 2, 3, 4. G is equal to 1, 2, 3, 1, 2, 4. This implies f and the g are they have common element. Common element is here. Joint element is 2 and 4. Here is also 2 and 4. Because of this 2 and 4, we say that f and g are not disjoint. It was the class of 69. Thank you.